All right, so now we'll be given a graph and then find the equation just like we did with parabolas. So all right, we'll graph the vertices and the foci. We don't know where the co-vertices are. That's a vertex is a co-vertex. The ellipse must be going like this, but we don't know how far to go this way. So let's look at the standard form of the equation. X minus something squared over something squared. Once we know all these numbers, then we're done. And we already know that the center is between the two vertices, and that means we have zeros there. We need to have the horizontal distance. We already know the vertical distance because that is 8. So this is going to be 8 for the vertical distance from the center to a vertex. And we know C. C is 4. A is 8. And if we know A and C, we can solve for B. B is right there. So we'll use the formula for the foci. C squared equals A squared minus B squared. 8. And we have 16 minus 64. So we have x squared, y squared, 64, and then we're going to have 48 squared. So I copied the 8 from there, that's 64, and then I square this, so it's just going to be a 48. So what usually happens is we just look at what we have, usually find 2 lengths on the graph, and then we'll solve for the third length. Same question with foci at 0, 0 and 4, 0. Vertices here, and you find the equation of the ellipse. Pause the video. Foci, vertices at -1, 0, 5, 0, and the center must be right there. The ellipse is going like that, but we don't know how far to go this way. So let's look at what we do know. We know that A is 3. And we know that C is 2. We're trying to fill in all of this. We do know the center, so this moved to the right 2. We put a 2 there. It didn't move vertically, so that's a 0. The horizontal distance to the vertex from the center to the vertex is 3, so that means under the x, because x is horizontal, we'll put the horizontal distance. Then we just have to find this, the vertical distance. So we'll go back to c squared equals a squared minus b squared. B is square root of 5. That means if we put the square root of 5 right there, we'll just have a 5 in the denominator. So the final equation is same question. But here we just get tested on the vocabulary. Major axis of length 12 and the foci. It really ends up being the same information, same problem. Foci, over 2 up 0 and left 2 up 0. The major axis is always along, the foci are on the major axis, so we know that the major axis must be where the foci are. If the major axis has a length of 12, then that means half of it is out here at 6 and negative 6. The ellipse will be going like this. We don't know how high it'll go, but we know that A equals 6 and C is 2. And we are trying to complete this. Right now, the center is at 0, so we know these numbers. A is 6, and A is horizontal, a horizontal distance, so it's under the x. Then we just have to find B again. C is 2, A is 6, and B is what we're going to solve for. 4 minus 36, negative 32 is negative b squared. So square root 32 is b. Then we'll put radical 32 in here. And we have x squared over 36, y squared over 32 is 1. All right, and pause the video, try this problem. over 0 up 3. The major axis is the y-axis because that's where the foci are, and it has a length of 10, so we need to go up. There's the vertex, down 2 more for a total length of 10. So we know it looks like that with A equals 5, C equals 3. The center is 0, 0. We know the vertical distance is 5, so that's going to go under the y. C is 3. And then we have 5 squared minus b squared. This will be negative 16 divided by a negative is a positive, and then we square root. So b is 4. And that means we'll have a 16 if 4 goes there, and we get a 16. Here we have a 25. Okay, vertices 1, 2, and 4, 2. And it's saying that there is a point on the ellipse at 2, 1. So we can see that the center will be between the two vertices, and then that point is on the ellipse. So the ellipse will go around like that, and we know that that point is on the ellipse. So let's see what we know in the standard form of the equation. All right. We do know the x value of the center, and that's going to be 2.5. And we know the y value of the center, that's 2. We know the horizontal distance to the vertex, which is 1.5. But we don't know the vertical distance. We have 1, 2, 3 unknowns, but over here with this point, it gives us an x and a y. And that's how we just substitute for x, substitute for y, and we can solve for b. So x is 2. Y is 1. And if we have 2 minus 2.5, that's 0.5 squared is 0.25. 1.5 squared is 2.25. Here we'll have a 1, because it's 1 minus 2 is negative 1, squared is 1. And I think it's easier to do this with fractions, 1/4, and this is 9/4. And 1/4 divided by 9/4. 1/4 divided by 9/4 is 1/4 multiplied by the reciprocal. So we can see that's just 1/9. And we could have 1 over b squared equals 1 minus 1/9. And we are going to do the reciprocal of both sides and square root. So we'll get 3 over radical 8. And we might want to just leave it as radical 9/8 because we're just going to put it back into the equation. And we'll have x minus 2.5 9 over 8 square root squared and this will be 1 1/8, so 1.125. So we're squaring the radical, it'll go away, and we have 9 over 8. 8 goes into 9 once, and 1/8 is left over. That's 0.125. Same type of question with vertices and a point. All right, pause the video and try that one. So here are the vertices, and there's a point at 2, 0. So it's looking like this. And we can find the center. If it goes from -2 up to 3, we can look for the center. And the center will be at 0.5 here. If the total length is 1, 2, 3, 4, 5, we need to go up 2.5. 1, 2.5. So we know that the center is over 1, up 1/2. All right, and we have the x value is 1 of the center, and the y value is 1/2. The horizontal distance to the ellipse is unknown, but the vertical distance is known, and that is 1, 2.5. So 2.5, we can just write it as 5 over 2. And then we just have to solve for b. We know an x value of 2 and a y value of 0. So then we can substitute those. X is 2. Y is 0. (25/4). 2 minus 1 squared gives us 1. And we're going to square that. We get 1/4. 1/4 times 4/25. We're dividing by 25/4, so we multiply by its reciprocal. We get 1/25. So if we go 1 minus 1/25, that gives us 24/25. B squared is 25/24. And we don't even have to do the square root because we know we're substituting for b squared in the standard form of the equation. B squared is 25/24. And here we have 25/4 from the first equation that we wrote, 25/4. And then let's just review circles. Okay, two different questions. And if we have the center at 1, 2, 3, 1 with a radius of 2, and then for the equation of a circle, we have x minus h plus y minus k squared equals r squared. Then we just substitute the x value of the center is 3. The y value of the center is 1. And the radius is 2 squared. And this, a tangent, we haven't seen that word before. Well, we've seen the word, but we haven't seen it with this definition. So the center's at 4, -2. And it doesn't tell us the radius. But a tangent looks like this. If you have a curved line, the tangent is a straight line going next to the curve. So at x equals 6 is the equation of a vertical line, 1, 2, 3, 4, 5, 6. So we have a vertical line like this that is right on the edge of the circle. That means the circle must go to this line, 2. That means we're going out 2 that way, up 2 and down 2. And that tells us what the radius is, because the tangent is at 6. So then we can fill in the equation. R squared. R is 2. And then we have 4 with -2 there. And that's the end of this lesson.